Hello students, Miss Slyman here, and now we're into topic 1.1 still, but we're talking about sigma notation in these videos. So let's start with defining a partial sum. So a partial sum means it's only part of a sum, it doesn't go to infinity. It's the sum of the first n terms of a sequence. So if each individual term is our t sub n, then we denote our partial sum using either a capital S sub n, or we can use sigma notation. So in this case, we're indicating that we're starting with the first term and going to the nth term. And our I down here denotes what we're plugging in these numbers. So these numbers, we're going to go from 1 to n, increasing in numeric order. So we'll plug in 1, 2, 3, 4. So expanding this means I would start with t sub 1 because I have my 1 down here. And then I'm adding, it's a summation. So this is the capital Greek letter sigma. And so it's the capital S of Greek letters, and it means to sum. So I'm starting with 1, and then I'll plug in 2, and keep adding until I hit my top number here, in this case is n. So let's look at some specific examples. So we want to write the following in sigma notation for a sequence with general term t sub n. So the first 25 terms, so my sum of 25 terms means I'm going to start with the first term and end with the 25th term. So I want my t sub i's. So remember, this implies that we're going to take t1 plus t2 and keep adding until we hit the 25th term. All right. In this case, I'm not starting with the initial term. Now I'm starting with the 5th term, ending with the 20th. So I don't have a shortcut here for S sub n because I don't automatically know my number of terms. We'll talk about that in just a second. So I'm just going to start with the sigma notation. So in this case, I'm going to start with 5 and end with 20. For t sub I. So remember, this means I'm going to plug this number in first and then keep going consecutively up until I hit 20. So I'll have the 6th, then the 7th, all the way up until I hit the 20th. So my question of how many terms is this? Because down here, my n, remember, is my number of terms. Well, instinctively, you might want to say that it's 15 terms because 20 minus 5 is 15. But note that what we really have here is if we had the first 20 terms, that would be S sub 20 would be the same as going from 1 to 20 of Tn. But what we really have is starting at 5. So we're going to take this and then subtract off. So this was S sub 20, so I'm going to erase this now because now we're not talking about just S sub 20. But to get this, I would take my full sum and subtract off starting with 1 and ending at 4. So this is equivalent to the full 20 minus the first 4. So I've got 20 terms minus 4 terms. This means I actually have the sum of 16 terms. So in this case, this is 16 terms. So I could think 20 minus 5 plus 1, or I could think all 20 terms minus the first 4 terms. All right, I want the sum of the first 10 terms with even term numbers. So if I think about that, that's going to be T2 plus T4 all the way down, and I want 10 terms total, so 1, 2, my 10th term is going to be T20. So I'm trying to make these even term numbers. So that's the sum. I'm going to start with I equals 1 and end with 10 to make 10 terms, but this case I want my term number to be even, so I'm going to say 2i to make even term numbers. So remember, plug in 1. That would give us t2 times 1 plus t2 times 2 plus t2 times 10, which is what I thought instinctively. So there's a few examples of sigma notation. In the next video, I'll look at these expansions.